Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Now we have question 2. A sound wave is traveling through water. What is possible speed of sound for this wave? Okay, you have to know that speed of sound differs from one medium to another medium according to how the molecules are closely packed or spread out, or they move random in all direction at a high speed like in a gas state. So you can estimate that speed of sound, okay, in solid state is much greater than in liquid state, which is much greater than in gas state, okay, according to how the molecules are arranged. And in topic 3, in topic 2, thermal physics, you will know more about states, and you can check classwork and the homework for this topic. Okay, so you can estimate what is the value of speed for sound waves in water, which is liquid. In liquids, we have a range, approximately it's 1500 meter per second. In gas, like in air, it's about 330, 350 meter per second. In solids, it's faster. It can be 5,000 meter per second, almost 6,000 meter per second, and so on. Okay, so you can estimate. It's not an accurate. You can just estimate values, but you know the concept that sound travel faster when the molecules are closer to each other, which allow them to travel and transfer the energy faster. Okay. Let's go to question 3. Okay, question 3, we are discussing ultrasound. What do you mean by ultrasound? Now you have information about ultraviolet waves. Okay, please don't get confused between ultraviolet and ultrasound. And to make it more clear, you should know that ultra means extra. So ultraviolet, it means the frequency of ultraviolet radiation exceeds the frequency of violet. And for ultrasound, we mean that it's sound wave, it's longitudinal wave, but its frequency exceeds the value of audible frequency of human hearing range. Okay, so that's why we are calling it ultrasound. So the speed of ultraviolet here is given to allow you to just differentiate between ultrasound and ultraviolet radiation. Okay, so the speed is not related here, no change in speed. Ultra refers to frequency, not to speed. So you have to exclude any high speed here. So you have to exclude B and D, because speed of ultrasound, it has a range like the speed of sound in air. Since here we are talking about the speed of sound in air, so now we are discussing also ultrasound wave in air. So they will be the same speed. The only difference will be in frequency. And how ultrasound is produced? They are produced when we have like a crystal, and this crystal is vibrating, producing oscillations and vibrations. This oscillations and vibrations producing sound of high frequency. Okay, when we apply electric field to certain crystals, these oscillations and vibrations take place, producing sound of high frequency. Is it clear? Okay, so now you have to choose between A and C. A and C. The correct answer is C, because you have to choose a high frequency exceeding the audible human hearing range, which is between 20 hertz and 20 kilohertz. So you have to choose a value exceeding this value. So again, please write down what do you know about ultrasound waves now that their frequency is exceeding the audible range frequency, and they are made by electric field applied to a certain kind of crystal, and this producing oscillations of sound which has high frequency. Is it clear? This question also is challenging and it's very important. Okay, let's move to question 4. The diagram representing two different sound waves. How do the frequency and pitch of P compare with the frequency and pitch of Q? Okay, this question is very important to differentiate between pitch and what you know about loudness. Okay, so one of the features of any sound waves that you can say that this sound, it has high pitch or it has low pitch. Another feature, that sound is loud or sound is quiet. Okay, what can be an indication for loudness or quietness of sound? Loudness and quietness is related to amplitude. Okay, but high pitch and low pitch is related to the frequency of the source. Frequency of the source. Is it clear? So frequency of P and frequency of Q. Let's compare here the diagram. You will see that number of waves per second, they are the same. You have here P, you have 1 complete wave, you have 2, you have 3. Okay, and wave Q also, you have 1, you have 2, you have 3 during the same time, which means they have the same frequency. So now you have to exclude B and A. So frequency of P and frequency of Q, they are the same. What about the pitch of P and the pitch of Q? Also, they should be the same. Why? Because we said that pitch and frequency, they are related to each other. The higher the pitch, it means the higher the frequency of the source. So the answer is D, because we have frequency and pitch. There is a relationship between them. And also for other questions, you should know that loudness, higher the amplitude, the greater the amplitude, it means louder sound. Okay? Okay. Question number 5 is very important, also discussing echo, which means repetition of sound due to reflection. And we have many applications and many important uses for sound in our daily life. If you would like to know more about uses of ultrasound and uses of echo in our daily life, you can follow our Instagram account, and you have to answer RBL questions, research-based learning for general knowledge, and it's very beneficial. Okay, we have a pulse of sound is produced at the bottom of a boat, and you have this sound travels and reflected from seabed, and it will reach the boat again after 1.2 seconds. The speed of water here, the speed of sound, in water is given, and you know this value. Okay, it's just an estimation. You can estimate the value of speed of sound in liquids. How far below the bottom of the boat is the seabed? So you would like now to apply the equation we used usually for calculating echo time and calculating the situation for reflection of sound in general. What is this equation? You know that speed of sound in water, speed in general is equal to distance divided by time. But the distance we have here is depth of the sea. And the time we have here, it's echo time. But if you look at the situation we are having here, the sound waves, they travel to seabed and then reflected back. So the distance traveled by these sound waves, it's 2 times depth of the sea, twice depth of the sea. So when you substitute here, speed of sound in water is equal to 2 times depth of the sea, which is unknown, and you have the echo time is given, which is 1.2 seconds. Check that all the units are consistent and you are using correct equation. Okay. Rearrange, you will find that, I will write here, it will be depth of the sea will be equal to 1500 times 1.2 divided by 2, which is 900 meters. Okay, there is an important point, guys. You have to check your answers. They should be realistic. Don't just write down what is produced in your calculator, because sometimes maybe you just enter wrong values and you can got unrealistic values. So if you got, for example, depth of the sea is 9 meters, this is not realistic. Okay, so please check that you have realistic values. So 900 meters, which is answer B.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.